Hello, welcome to Succeed e-learning app. Today's chapter is Constructions. In class 9, you have learnt various constructions, for example bisecting an angle, bisecting a line segment through a perpendicular, and some constructions related to triangles, and you have also seen how to justify it. In today's class, we are going to learn of more constructions. Division of a line segment. Suppose you're given with a line segment and you're asked to divide it in a ratio, let's say 3:2. So how are you going to do it? You are going to precisely measure 3 centimeter and 2 centimeter, mark the points and then divide the line segment. Let's say that there is any way wherein which you can precisely measure and divide the line segment. So how are you going to do it? So in this chapter, in this method, you are going to see how you will be doing the same division of the line segment in a different method. So here is how we are going to do it. Given a line segment AB, we want to divide it in the ratio m:n, where m and n are positive integers. To help you understand with it, we shall take m is equal to 3 centimeter and n is equal to 2 centimeters. Now, let us look at the steps of construction. We have been given with line AB. Now, place the protractor at point A and mark a point at 30 degrees. You can actually take any acute angle. For example, I have taken 30 degrees. Now, extend the line from point A to X at the point 30 degrees. Now, locate 5 centimeters from point A, that is on the line AX. Take a compass and measure 1 centimeter. Now, start marking arcs from A until A5 or the 5 centimeter line, such that each of the arc is separated by 1 centimeter each. That is, place the compass at A, mark an arc of 1 centimeter and place this as A1. Now, shift the compass to A1 and again cut an arc at A2, which is again 1 centimeter. Similarly, mark the points A3, A4 and A5. Now, join A5 with B through the point A3. So, if you observe that A3 is 3 centimeters away from point A. So, through the point A3, draw a line parallel to A5B by making an angle equal to A5B at A3, intersecting AB at point C. Now, if you look at the figure, we have AC, which is equal to 3 centimeters, and CB or BC, which is equal to 2 centimeters. Let us see how this method gives us the required division. Since A3C is parallel to A5B, we can write this as AA3 by A35 is equal to AC by CB. This is by using the basic proportionality theorem which we learnt in Triangles chapter. Now, from the given, we know that AA3 is equal to 3 centimeter and A3A5 is equal to 2 centimeter. If you substitute that in the proportions, we get AA3 by A35 is equal to 3 by 2 is equal to AC by CB, which proves the fact that AC by CB is also equal to 3 by 2 or 3:2, and hence AB is divided proportionately in the ratio 3:2. Construction number 2. To construct a triangle similar to the given triangle using the scale factor. So, what is scale factor? scale factor is the ratio of the side of a triangle that you are going to construct with respect to the side length of the given triangle. So now let us quickly see an example on how we are going to construct. Construct a triangle similar to a given triangle ABC with its side equal to 3/4 of the corresponding sides of the triangle ABC. This implies that the scale factor is 3/4. Now, we have been given with the triangle ABC and we are required to construct another triangle whose sides are 3/4 of the triangle ABC. Now, place the protractor at point B and mark any acute angle. Okay, so mark an acute angle at a point. So name this point as X. Draw a line from B to X and also extend it for a safer side. Now, place the compass at point B, measure 1 centimeter and cut an arc on BX. Let me tell you why. So here we are given that there is 4 centimeters and we have to divide 4 centimeter into 4 equal parts. So 4/4 would give you 1 centimeter. So you have to mark 4 points which is 1 centimeter away from each other. Now from B, cut an arc at 1 centimeter on BX and name this as B1. Also, the given scalar factor is 3/4. 4 being larger than 3, we know that the new triangle that has to be constructed is of the side length 3 centimeter. Now, B3 is 3 centimeter away from point B. Therefore, join B3 and mark a point C dash on BC in such a way that B3C dash is parallel to B4C. Draw a line through C dash parallel to the line CA to intersect AB at a point A dash. Then we have triangle A dash B C dash, which is the required triangle. This is what we have been asked to construct. Now, let us see how this construction gives the required triangle. Through this construction, we know that BC dash by CC dash is equal to 3/1. Therefore, we can write this as BC divided by BC dash is equal to BC dash plus CC dash divided by BC dash. Now, taking the common factor out, that is BC dash, we can write it as 1 plus CC dash divided by BC dash, which is equal to 1 plus 1/3. On cross multiplication, you get 3 ones are 3 plus 1, which is 4, 4 divided by 3. Therefore, you can write this as BC dash by CC dash is equal to 3/1. Also, BC dash by BC is equal to 3/4. Also, we have C dash A dash, which is parallel to CA. Remember the basic proportionality theorem. Through that, we can write it as BA dash by BA is equal to BC dash by BC, which is equal to C dash A dash by CA, which is equal to 3/4. And hence, this justifies the construction that we have done so far. In the previous exercise, we saw how to construct a smaller triangle when the bigger triangle has been given. So in this exercise, let us see how to construct a bigger triangle when a considerably small triangle is given. The question is here. Construct a triangle similar to a triangle ABC with its side equal to 5/3 of the corresponding sides of a triangle ABC. So this implies that the scale factor is 5/3. A quick tip: whatever is in your denominator is your reference triangle. So in your previous example, it was given the scale factor was 3/4, where 4 was the side length of the actual triangle that was given to us. So in this example, we have been given with a scale factor 5/3, which references that the given triangle is 3 centimeter of side length. Now, let us look into the steps of construction. Draw any ray BX making an acute angle with BC on the side opposite to vertex A. So to do this, what you have to do is place a protractor at point B and mark a point X which makes an acute angle with BC. Now, join the line BX and extend it as we always do. We have been given with the scale factor 5/3. The greater of 5 and 3 is 5. So, we have to mark 5 distinct points on the line BX in such a way that each of these are 1 centimeter away from each other. So, as we already did, place a compass on point B and measure 1 centimeter, cut an arc on the line BX. Mark this point as B1. Similarly, mark B2, B3, B4 and B5. Now, extend the line BC to a certain distance. Try to place the compass on point B5 and mark a point C dash. Now, join B5 C dash. Now, join B3 with C. Also, draw a line from B5 which is in parallel to B3C to an extended line segment in such a way that you get B5C dash. Draw a line through C dash parallel to CA intersecting the extended line segment BA at A dash. Then A dash B C dash is the required triangle. For the justification, let us look into the construction. So note that triangle ABC is similar to triangle A dash B C dash. Therefore, we can write this as AB divided by A dash B is equal to BC divided by BC dash is equal to AC by A dash C dash. But we know that BC by CC dash is equal to 3/2, or we can also term it as BC dash by BC is equal to 5/3 through the construction. Therefore, we can term this as A dash B by AB is equal to A dash C dash by AC is equal to BC dash by BC, which is equal to 5/3, and hence this construction is justified. So far, we have learnt how to bisect the line segment and also how to construct triangle which is bigger than or smaller than the given reference triangle by using the construction method. So now, let us see how we are going to construct a tangent to a circle by using the construction method. Let us quickly recollect the method or concept of tangents from your previous lessons. So, at any given point which is inside the circle, there is no possibility to create or draw a tangent. At any given point on the circumference of a circle, there can only be one tangent which can be drawn to the circle. And at any given point which is outside the circle, there can only be two tangents to the circle. In this exercise, we are going to construct two tangents from a point which is outside the circle. Let us look at it. We are given with a circle with center O, and at a point P outside it, we have to construct two tangents from P to the circle. Steps for the construction is here. Step 1. Join PO and bisect it. So, bisect it at a point which is the middle point of OP or PO. Name this point as M. Now, taking M as center and MO as radius, draw a circle and let it intersect the given circle at the points Q and R. Now, join PQ and PR. So, if you observe it closely, the PQ and PR are the required two tangents of the circle. So, now let us see how this construction works. Join OQ, then angle PQO is an angle in the semicircle. Therefore, angle PQO is also equal to 90 degree. That is, OQ is perpendicular to line PQ, which means this angle Q or OQP is 90 degree, that is right angle. Since OQ is the radius of the given circle, PQ has to be the tangent to the circle. Similarly, PR is also the tangent to the circle. Now, you have to note that if the center of the circle is not given, you may have to locate the center so that this construction could be performed. To summarize, in this chapter, you have learnt how to bisect the line segment. You have also learnt how to construct a triangle which is similar to the given triangle by using the scale factor. So, it can also be a smaller triangle or a larger triangle with reference to the given triangle. Also, last but not the least, you have learnt how to construct tangents to the circle from a point outside the circle. I hope you enjoyed learning with us. For more such video, keep watching Succeed e-learning app.